In this example, we are going to use noise to obtain the frequency response of a black box system. By black box system, I mean a system that we don't have any information about, that we don't know what it does. The only thing we know, we can pretend is just a black box that we can feed in some input signal and we can measure the output of this black box. The idea here is to use noise because it has approximately flat frequency spectrum. So all the frequencies we are interested to investigate are present in this input signal, and we will make use of the concept of transfer function. So in the frequency domain, we will divide the output of this black box by the input signal. This gives us a transfer function, and when we take the inverse Fourier transform of this transfer function, we will end up with an impulse response of the system. Here we are loading some Python libraries. So we are going to use SciPy to calculate the FFTs. We are going to use matplotlib and plotly to plot. And these are the signal processing parameters we are going to use for this example. So we're using a sampling frequency of 32 kilohertz and a number of FFT points, 2 to the power of 16 points. So that's approximately 65,500 and something. So the time interval we're going to use to generate our signals will be approximately 2 seconds. So we are using 32 kilohertz sampling frequency and 2 to the power of 16 points. That gives us approximately 2 seconds.